If you have mastered your angle pairs, today's lesson should be pretty easy for you. The only difference in this lesson is that those two lines that are crossed by the transversal, those two lines are going to be parallel, and that allows us to do a lot of things with those angles. The first thing I'd like to show you is called the corresponding angles postulate. It says that if those two lines are parallel, those corresponding angles, can you see how you could kind of just slide that other angle down here and it should be a perfect match? These two angles wind up being congruent to one another when we know that the lines are parallel. And so on this example down here, I see those parallel markings on those two lines, and they're telling me that this angle right here is 125 degrees. By the corresponding angles postulate, what other angle can we tell the measure of? Well, the angle that's corresponding to that one is the one that's in that same relative position at the other intersection. So by the corresponding angles postulate, we can say that the measure of angle 7 also equals 125 degrees. Now the corresponding angles aren't the only ones that are congruent. We have three more theorems that tell us about other relationships between angles when we have parallel lines. The alternate interior angles theorem: if two parallel lines are cut by a transversal, then the pairs of alternate interior angles are, do you see angle 4 right here? And angle 5 should be an exact match to that if those lines are parallel. So we could say they are congruent. That one's a theorem, not a postulate, because we can prove it using the corresponding angles postulate. For example, we know that angle 4 and this vertical angle would be congruent, and then these two would be corresponding angles. So we could make a proof of that. All three of these theorems can be proven. This one says if two parallel lines are cut by a transversal, then the pairs of alternate exterior angles are congruent. And this last one is just a little bit different, so pay attention. Consecutive interior angles theorem. If two lines are parallel and cut by a transversal, then the pairs of consecutive interior angles, remember sometimes we call those same side interiors, well, this time those are not congruent. If you look at that, doesn't angle 3 look acute and angle 5 looks obtuse? So the punchline here is that angle 3 and angle 5 are supplementary. Consecutive interior angles are supplementary. Here's a fun little algebra problem that will use one of those theorems or postulates. I see those parallel lines. That's the first thing you're going to always want to look for. And then what types of angles are marked here? Well, they're both on the exterior, and they're on opposite sides of this transversal. So those would be alternate exterior angles. And what does the alternate exterior angle theorem say? It says that if we have those parallel lines, then those angles are congruent. So the 113 has to be equal to the 3x minus 4. We'll solve that up. And I get x equals 39. Remember, I always like you to check that back in the picture, so if I plug in a 39, and that's a good sign because those two are congruent to one another. I don't think you need a ton of examples on this, but just remember, had I given you some algebra thing for this angle and this angle, we wouldn't set them equal to each other like we did in this problem. Those consecutive interior angles we would set up as that angle plus that angle equals 180, because consecutive interior angles or same side interior angles are supplementary. So you just have to watch that. Either the angles are going to be equal or they're going to add up to 180. And if you hadn't already guessed, we will be doing some proofs with these new theorems, so let's add those to our reasons list. And you choose on this last one if you want to call it same side or consecutive interior angles. And I like to make those little notes off to the side to help you. So for all 4 of these, I think we should just make a note that all of these start with if we have parallel lines, then we can say something about the angles. For most of these, the angles are congruent, but on that last one, remember that the angles are supplementary. Then I just wanted to help you get started on a proof from the worksheet. Number 1 says, given that angle 2 is congruent to angle 3, prove that measure of angle 1 equals measure of angle 3. And the first thing they want you to fill in is given in the diagram. And I don't see any swoops, I don't see any algebra over there. One thing I do see is these little arrow markings. So that's the given in the diagram, that line K is parallel to line M. And it's a good thing that those are parallel, because then I can say that angle 1 is congruent to angle 2, because those are alternate interior angles. And then the given was that angle 2 is congruent to angle 3. I might mark that on the picture too. Angle 2 is congruent to angle 3. And angle 2 was already marked, which starts to make me think that maybe I have a train, right? If 1's congruent to 2 and 2 is congruent to 3, then 1 is congruent to 3 by the transitive property. And here's this old step where if the angles are congruent, then the measures are equal. Definition of congruent angles. On that same worksheet, number 4 is something called a flow proof. All it has is it has the statements in these little boxes and then the reason that goes with that statement on the side. And it just is sort of a visual way of seeing how that proof all comes together in the end. So the thing that you're trying to prove will come in this final box, and your final reason will go right there. Just do your best.